We'll begin Chapter 3 looking at linear equations in what's called standard form. That's when x and y are together on one side of the equal sign. Here we're asked to find 5 solutions of this particular equation. One thing that you have to understand is that when you're looking at a linear equation, any two variables, any two values that satisfy the equation are a solution. So there are infinitely many solutions. The first two that I would start with if I were finding some solutions are values of 0 for x and for y. So if I put in 0 for x, then one solution is the point 0.8. I can also put in 0 for y, so another solution is the point 6, 0. These are both pretty important because what we've got here is a y-intercept and an x-intercept. I could plug in any values really for x and y and come up with solutions, so I'm not going to find 5. But that's the purpose of understanding this, is that any ordered pair that works in this equation is a solution. Taking a look at this next problem, we see Robert has $22. He buys some notebooks that are $2 and some binders costing $5. If he spends all $22, how many of each does he buy? Well, let's let notebooks be represented by N and binders be represented by B. So we spend $2 on every notebook and $5 on every binder, and we spend exactly $22. So there are a lot of values of this that will actually work. Let's say we buy one notebook. That means that he has to have bought 4 binders. What if he buys 2 binders? That means he has to have bought 6 notebooks. These are all solutions to this particular equation. So here's one that says we have a 2-digit number and the tens digit is at least 5 more than twice the units digit. So what I might say is the tens digit at least means greater than or equal to 5 more than twice the units. So again, if we're going to look for all positive integers with this property, what if the units digit is 1? That means that the tens digit has to be 5 plus 2, larger than or equal to 7. So we're looking at 71, 81, 91. What if the units digit is 6? Five plus 12. Can this work? Nope, it can't work because we can't have a tens digit that's double digits. Okay, what if the units digit is 3? Nope, that won't work either. What if the units digit is 2? Well, my tens digit can be 9, so 92 will work. What if my units digit is 0? So now we're looking at 50, 60, 70, 80, 90. There are your values. The second section of Chapter 3 talks about graphing. The coordinate system that you're used to looking at is called the plane rectangular coordinate system, or the Cartesian coordinate system. You're familiar with the quadrants because we did that in trig, and of course the center is called the origin. Horizontal line is your x-axis, vertical line is your y-axis. This idea of one-to-one correspondence means that for any ordered pair, there is exactly one location on the coordinate plane. We're going to start with something insanely easy, plotting points, just to make sure we're all on the same page. So if we start with -1, -3, that means we go -1 on the x, -3 on the y. So there's my point. The point 3, 3, +3 on the x, +3 on the y. 0, -4, that means 0 on the x, down 4 on the y. 3, -3, +3 on the x, and -3 on the y. 4, 0, +4 on the x, don't move anywhere on the y, so we're right there. Next, we're going to look at graphing lines, and I'm actually going to start with these two lines here. If we're looking for a line where y is equal to -2, what we have to do is locate -2 on the y-axis and plot points where y is equal to -2. Well, it's -2 here, and here, and here, and if we go backwards. So y is equal to -2 is a horizontal line. If I'm looking for the line x equals 3, I have to locate 3 on the x-axis and plot points everywhere where x is equal to 3. So it's 3 here, and here, and here, and backwards as well. So x equals 3 is a vertical line at 3. Next, we'll take a look at the line y minus 2x equals 6. On something like this, because y does not have a coefficient, and the coefficient on x is negative, I would actually rearrange this equation, meaning I would add 2x to both sides, and I would get y is equal to 2x plus 6. And we can look at this the way that we've looked at lots of equations. I'm going to count by 2's here. 6 is my y-intercept. My slope is 2. That means I have to move up 2 units and over 1 unit if I count this x-axis as being 2's as well. That means that my next point is right here, up 2 over 1. I can also move backwards, so I can go from here down 2 over 1, down 2 over 1. So there's a point here and a point here, and then I can graph this line. On one like this that's in standard form, I would actually recommend that you graph this by intercepts. What that means is locate your x-intercept, locate your y-intercept, plot those 2 points, then connect your 2 lines. This is actually a very simple one. My x-intercept, what I have to do is set y equal to 0, and hopefully this red dot is covering up the y. That means x is 7 when y is 0. So I can plot that pretty simply. Let's call this 6 here, so 7 is right there. And x is 7 when y is 0. I can do the same thing on the y-intercept. I just set x equal to 0. Y is equal to 7 when x is 0. So if this is 6, we'll call that one here 7. So this line connects these 2 points. Finally, you need to understand that anytime we have an equation in this form, it's called standard form. And as long as a and b are not both equal to 0, we have a line. You only need 2 points to graph a line, and I would always recommend x and y intercepts if your equation is in this form.